Finally, let's plot it up all together for Tafel, for Butler-Volmer versus experiment data for the same anode polarization data for chlorine gas production using sodium chloride solution, okay, at 20 degrees C. So this is a plot. The horizontal axis is eta, or anode overpotential, which is the potential difference between the actual potential while in this case chlorine gas is produced versus the equilibrium potential between chlorine ion and the chlorine gas. Okay, that's the overpotential, and the vertical or y-axis would be current density in the unit of amps per meter square, and I'm plotting the current density in log scale from 10 to 100 to 1000 to 10,000 to 100,000 amps per meter square in log scale. Okay, and then the red circle represent experimental data. Red circle represent experimental data, and the black circle represent experimental data. The red square represent the current density corresponding to different overpotential calculated directly using Butler-Volmer equation, using our fitted Butler-Volmer equation kinetic parameters such as 1 minus beta and J0 exchange current density. The blue triangles represent the data from Tafel fitting, the data from Tafel relationship, also after optimization and fitting. Okay, that's for the blue. And again, we said the Tafel relationship would follow a linear relationship between log of current density and overpotential. And here we clearly see that when the current is above around, I would say 100, when the overpotential is above around 0.1 volt or 100 millivolt, and below 0.1 volt, there might be slightly larger difference, and it really starts to get more significant when the overpotential is greater than, it's smaller than 0.05 volt or 50 millivolt. Below that, you can see the difference between the Tafel relationship and the experiments would become more and more significant. So overall, we have good fitting at high overpotential for both blue representing Tafel relationship as well as red represent Butler-Volmer relationship. But when the overpotential is lower, below 50 millivolt, let's say around the 20-30 millivolt, the difference in calculated by Tafel or calculated by Butler-Volmer would be much higher than the experimentally measured value, and it's become more and more significant as the overpotential goes lower and lower. And also one more thing is that this deviation between experimental value versus modeling is more significant or more obvious for the Tafel relationship than for the Butler-Volmer relationship. Okay.